Hey there and welcome back. So today I want to show you how I made this thumbnail picture that I have been using for the videos on the course. So this is actually running in my Commodore 64 emulator right now. So this is not just from Microsoft Paint, this is actually running on the Commodore 64. So how did I do that? Well, there is one graphics mode that we haven't looked at yet, called Bitmap graphics mode. So let's look at that now. So here I am in a great application called Multipaint. Now Multipaint is an application both for Windows, Mac, and I think it works for Linux as well. But right now I can't get it to work on my Mac, and I think once again it's because of the Java version. But I have it running here in Windows. So what this is just a paint program like we used to from Microsoft Paint or anything like that. It's just, you can just start drawing, stuff like that. And we can also color in, just like we used to in Microsoft Paint. So basically, what this does, this is of course a modern application, but this lets us draw pixel by pixel on the Commodore 64 screen. Now normally we are used to working with these character cells. So we have one A up here, and then maybe a B, C, and so on. And that's how we have been making background graphics, by using these cells and screen codes. But this is a completely different mode on the Commodore 64, where we can just draw with pixels like that. Now in this case I'm drawing with multicolor, but we can also draw with high resolution. Now the colors of course apply to the same rules as before. So when we're dealing with high resolution like this, now we can just have two colors in one cell. So if I have a lot of yellow in this cell now, then so there's a cell with only yellow in here now. Now I can draw with one more color in there. So let's see if I can have some purple in here. So now I have yellow and purple in this cell, but I can't add another color. So when we're dealing with multicolor, it's just two colors per cell. Now for high resolution mode, we can just have two colors per cell. But we get these smooth pixels. For multicolor, we can have three colors, or actually four colors when we include the background color. So we can have four colors per cell. So if I zoom in here, I can have green. I have to change the mode first. So I'm going to multicolor. So now I can have green, cyan, yellow, and black here. So four colors per cell. So this is how the Bitmap graphics mode works on the Commodore 64. Just drawing pixels on the screen. But now I'm using Multipaint. What did they do back in the 80s? In 1983, Koala Technologies released this thing, the Koala Pad, which is just a graphics pad that you can connect to your joystick port on your Commodore 64 and just use this little pen to draw on the tablet like that. So this was pretty advanced in 1983. And they also released a companion software called Koala Paint. So using this, you could actually paint with bitmap graphics on your Commodore 64, which was super advanced in 1983. So let's take a quick look at a clip from Computer Chronicles from 1988, where they demonstrate this Koala Pad.
Okay, can you show us some of the things you do with Koala Pad?
Sure, let me load this Koala Painter in. Okay, I have the menu here. What you would do is you could catalog the disk from that icon. You could save, get, or name and save, so we can just click on the get.
Okay, suppose we want to look at wackos there.
Okay, so we click on get and go up the wacko, press the button. I already have it loaded.
Okay.
This is the picture.
Okay, that's pretty good. And that is what? What did you create this for?
This was for a bulletin board that I knew the guy that was running it, and he wanted to...
The Wacko World board.
Yeah, the Wacko World, yeah.
Okay, can you pull up something else you're in the middle of working on?
Sure, just go to swap here, hit that. This is for a program, a menu program. All you would see is this screen here, and I could press A, B, C, D, F, G.
Suppose you wanted to add some artwork to that screen now. How would you do that?
Okay, there's a part down at the bottom I'm still working on. Go to zoom here, put the window down here, and touch up these letters. Select a color. So I want to get rid of that green line. I just do it pixel by pixel, or I could drag the pointer across.
And then you could just paint a graphic in that little space on the right if you wanted to, or
yeah.
anything you want to do there, huh?
This really, it's time consuming.
Yeah.
Well, one of the interesting things is that this is a video, composite video, same as your camcorders and so forth, so you could actually make titles and all sorts of things for your home videos.
So it's a pretty cool clip from 1988 Computer Chronicles. But anyway, here I am in my Commodore 64 memory map. So to enable bitmap mode, I need to change one bit there. In memory address D1011, screen control 1. So the bit I need to change is bit 5. By default, it is set to 0 for text mode. That's when we're using our characters or screen codes. But if you change bit 5 to 1, then you set the screen to bitmap mode. So bit 5 in D1011 needs to be 1 to enable bitmap mode. So, is that enough? Well, not really. Actually, using bitmap mode is a little involved. It's not super easy. So, the first thing we need to remember now we're not placing characters on the screen. So if you remember, we have 40 columns across and 25 rows down. So 1000 characters on the normal Commodore 64 screen. So that means that for each screen code, that's 1 byte. So 1000 bytes. Now, for the bitmap mode, it's a little different because now we need to keep track of every single pixel that we draw, which means we're gonna be using a lot more RAM. So if I take up my calculator here, and if you think about this, think about the Commodore 64 screen. We have a resolution of 320 pixels times 200 pixels. 320 times 200. So let's write 320 times 200. So this is how many pixels there are on the Commodore 64 screen. 64,000. Now, we don't store pixels like that in memory. As you know, memory addresses are 1 byte each, and 1 byte is made up of 8 bits. So 1 pixel in high resolution mode, 1 pixel is 1 bit. Now in multicolor mode, we know that we need 2 bits to have a fat pixel. But anyway, the point is that in order to store these pixels into memory, now we have done the math, we know that there are 64,000 pixels on the screen. But we're not going to store 1 pixel in 1 memory address. We can actually fit 8 pixels in 1 memory address. So if I divide this by 8, since one memory address can hold 8 bits. So 1 byte is 8 bits. So if I do that, then we end up with this, which means that setting up the screen to use bitmap graphics takes up 8,000 bytes in the Commodore 64 memory, because we need 8,000 memory addresses to keep track of all the pixels. Now, every memory address is going to have 8 bits, and one of those bits, each of those bits is a pixel in high resolution mode. Like we said just a minute ago, for multicolor we have 2 bits for a fat pixel. But the point is, we need 8,000 bytes to use this mode, which means that things are going to be a little different now. Now, if we look at the memory usage for this little program that I have here, now this program only displays this picture. It does nothing more. I don't have any sprites or anything like that. But if we look at Noice Kick Assembler memory viewer now, we can see that just by displaying this picture, I'm using a lot of RAM just for this. So we actually have 8,000 bytes here. That's just for the pixel area. So just to keep track of all the pixels here, we have this 8,000 byte area over here. So using this requires a bit of planning for memory usage. And also remember what we talked about last time, this thing about the VIC banks. So right now we are in VIC bank 0, so the first VIC bank. And we've almost filled the entire VIC bank with just this picture. So using this kind of things in games requires a lot of planning and yeah, maybe not such a great beginner friendly project, because just by setting this up, I only have this tiny little area here with memory that's free. So why would we want to use this? Well, it's really up to you. You can use it in a lot of different ways, and I have used it with a loading routine I had in my game. So when the game was loading in, I displayed this picture, so people could look at the picture instead of a black screen while the game was loading in. But again, it requires a lot of setup and planning. But how can we do this? Well, first of all, let me just admit right now, I'm definitely not an expert at this, and I don't even understand everything that's going on here. But we are going to look at an example here from the Kick Assembler manual, which is what I have been using. So this is pretty straightforward if we follow what it says here in the Kick Assembler manual. It actually has a nice example here that we can just copy and paste into our code. So basically that's what I've got going on here. I've modified it a little bit, added my own labels, stuff like that. But let's just notice right now that we are using a koala template. So sort of a koala file type, if we can call it that. So that's a file that I have exported from Multipaint. So that's pretty nice. We can draw a nice picture in Multipaint, export it, and just put it here in our code. So that's what I've done here. Now, we need to remember a few things now. Screen control 1 and screen control 2 is going to be important now. So if I go down to my main, so this is not a very big program. If I go down to my main label here, you can see that I start by setting the the D1018 address, screen memory setup. So I start by setting screen RAM to C100 and bitmap RAM to 2000. Now remember our calculation here. 320 pixels times 200 pixels, that's 64,000 pixels. But if we divide that by 8 bits for every memory address, you have 8,000 bytes. In hexadecimal, that's almost 2,000. Because we're not, a kilobyte, that's 1024. So it's not quite 2,000 here. But anyway, we need to fit this into the memory. So let's just go back to Noice Kick Assembler memory viewer for a second, just to make it easier to keep track of what we're doing. So now we are here at memory address 2000. So let's see if we can get them side by side here. So I just said bitmap RAM 2000 here. So memory address 2000 is here. So I'm gonna start filling in my picture from this address. And as we can see here, it's 8,000 bytes, so it's filled up here. So the way that that's done here in Kick Assembler is, if we go down here, I have my bitmap graphic here. So the picture itself, and that's at memory address 2000. So the way that works here, and we have an asterisk, equal sign, and then this. So as you know, that means that whatever comes after this, start filling that into memory, starting at this memory address. So in our case, it's 2000 now. So here we are using this kick assembler command .fill. And the way I understand it, it just fills in into memory. And here we are using this picture. Now I haven't mentioned that. Let's just do that first. If we go up here, actually before we start our basic Upstart 2, now there's a thing called .var here. That's a variable in Kick Assembler. So you can do a lot of stuff in Kick Assembler that isn't really assembly language. So for example, defining a variable like this, it's not actually assembly language, but if you know how to use it, then you can use it in your code, and when you run it through the assembler, Kick Assembler, then that's going to be translated to assembly or machine language. So I have to be honest, I'm not used to using this, and we also see this .const here that I mentioned a while back to make a constant. We have only been using labels. So there are a few things here that are specific to Kick Assembler. But anyway, this .var here, I'm creating some sort of Kick Assembler variable called picture. What we put into that variable, well, there's a function here in Kick Assembler called load binary. So that's where we're loading this actual graphics file with this Koala template. So like I said before, I'm no expert at this, but I'm just doing what the manual said for the Kick Assembler manual. But let's just think about it this way, that we're filling this picture in the correct format into this variable. So if we go down here again to bitmap graphics to memory address 2000, we're starting to fill in that variable, and this is also a Kick Assembler thing, that you can use some functionality with dot and then some method here. Get bitmap size. Picture get bitmap. So like I said, I'm a little outside my comfort zone now because there's a lot of stuff going on here that I'm not really used to. So a lot of specific Kick Assembler stuff here. If we take a look at our code here, there's also here, if you have programmed in other programming languages, you know that you can make for loops. So here's a for loop. No, that's not a normal assembly language either. So, but again, it's something Kick Assembler allows us to do. So like I said, there's a lot of stuff going on here. and I have been a little lazy. I haven't studied this very well, but I found that by using this example code from the Kick Assembler manual, I can basically do what I want. So usually when I'm dealing with bitmap graphics, I just want to display a picture and that's it. So that's what I'm doing here. I'm using the default or the example code here, setting it up with my own labels, my own memory addresses, and just loading in the picture. So I'm sorry I can't explain this in detail, but if you just want to display a picture, then it's actually pretty easy if you use this example code. So now let's look at an example from a game that I've made using this technique. So now we see what I was talking about. Now this picture is displaying right now while I'm loading some other stuff from diskette, like we saw last time. Now, of course, displaying a picture like this takes a little extra of the resources. So it takes a lot of memory from the Commodore 64 and takes a little extra time loading in the game. But I just thought that it was worth it, having a picture displayed while the game is loading in. So I just followed the normal setup from Kick Assembler manual to display this picture. So now this is displayed while I'm juggling something in the background. So, well, like I said before, now I need to load stuff in to different memory addresses because this is going on in VicBank 0. So I'm using up almost all the space in there for VicBank 0. So I need to load stuff into other memory addresses. And now I'm blanking out the picture because now I need to load stuff into VicBank 0. So obviously I can't display the picture because that's taking place in VicBank 0 now. So once I need to start loading stuff in there, I have to remove the picture. So in this case, I just disabled the screen. You remember we can disable the screen just by flipping a bit in screen control 1, I think, D1011. So this is just to show you an example. Oops. We just disable the audio for a second. So now I'm done with the bitmap graphics and now the actual game has started. So that's just an example of using bitmap graphics. So displaying a picture while you wait for the game to load, for example. Or there are actual games that use bitmap graphics in gameplay, the gameplay itself. Now, of course, that requires very intimate knowledge of how bitmap graphic works, but it's definitely possible. So this is just what I wanted to show you, how you can display bitmap graphics, and also that we know that there is a bitmap graphics mode on the Commodore 64. But like I said, I'm sorry I couldn't go further into detail here because this is not my area of expertise. But fortunately, the Kick Assembler manual has this example code for us that we can use, which makes it pretty easy just to load in a picture. As long as we remember that we need a lot of memory to use bitmap graphics like this. Alright, well, once again, I hope you got something out of this. That's it for this episode, and this is the final bonus episode. So basically that means that the course as a whole is done now, even the bonus episodes. So going forward now, I can't promise anything, but there might be an episode here and there just covering specific topics. I haven't planned anything right now, but since this is a channel both for tutorials on NES Maker, making Nintendo games, and Commodore 64, then there might be a little this and a little bit of that. So we'll see going forward, but there will probably be new episodes about Commodore stuff in the future. So, like I said at the end of the course, thank you once again for joining the course, and I'll see you later. Bye bye.